Okay, so in this example, we are going to be graphing the sine function for different values of h, where h is a value that you'll see shifts the function left and right. Okay, it's otherwise known as the phase shift. Okay, phase shift. Or you can just think of it as the horizontal shift. So let's start off with our first value for h, which is negative 30. I'm going to substitute it into my template here. And what I get is f of x equals sine of x minus negative 30, or just sine of x plus 30. Okay, well, we're going to zoom in here on our graph to look at some specific values for sine. I'm going to just copy my equation again. So I have f of x equals sine of x plus 30. I'm going to start off by substituting in a value of negative 30. So negative 30 is over here, if you don't see it, on my grid. I'm going to put f of negative 30. And that'll give me sine of negative 30 plus 30, which is just sine of 0, which is just 0. In other words, when x is negative 30, sine of x, or sine of negative 30, is going to be 0. Next, let's move over to the right. We'll go up by 30 degrees, and we're going to get f of 0. So f of 0 is just going to be sine of 0 plus 30, or sine of 30, which, if you recall, in your triangle, I'll do it over here. This is our 60, 30, 90 triangle. Again, I like to use this as a guide. 60, 30, 1, 2, and then we have a root 3. So sine of 30 is opposite over hypotenuse, or just 0.5, or 1 over 2. And if I go to my grid here, f of 0 is going to be 0.5, which is over there. Let's move on. Next, I'm going to have, let's do it over here, f of 30, which is just 30 plus 30, or sine of 60, which is 0.86 repeating. Again, it's root 3 over 2, which as a decimal, that's what it is. And if I want to plot that, I get at 30 at 0.86, which is roughly over here, a bit too big. And okay, looks like we have a little bit of a pattern. F of 60 is going to be sine of 60 plus 30, or sine of 90, which is equal to 1. If I plot that in, I'm going to be up here. And then I get f of 90. That's going to be sine of 90 plus 30, or sine of 120, which is equal to 0.86, repeating. And that's going to bring us over here. Sine of 120, well, it'll bring us over here. I won't bother to do the calculation, because I think at this point you can see where this is going. Sine of 180, again 180 plus 30, when you do the math, will bring us probably down here. Oops, a bit too big. Or here, then here, then here. And maybe by now you see the picture. Let's zoom out. Okay. So I'm going to just move these calculations off to the side. Again, if you're not convinced, do them for yourself. Oops. Bring these over here. I stole the dot by mistake. Bring this guy back. And I'm going to take these guys and take them out. And just move them to the side. Get this off the grid. You know what? I'll put this sideways. Okay, so let me connect the dots. This is the fun part. I'm going to get a curve that starts over here, goes up, comes down, comes to the bottom, then goes up again. And because this is repeating, I'm going to do from, negative 360 to 360. I'm going to get this again and put it over here. Gonna have to do a little bit of editing. Notice again, I did say the interval is negative 360 to 360. This is very important. When you are graphing, you want to make sure that your domain is accurate. So on the left side here, I'm erasing everything. And on the right side, I'm going to have to extend it a little bit up to 360. Okay, so you notice over here on the left, okay, it goes up to negative 360. And there we go. So what's different? You see, hardly anything other than the graph. The original sine graph has shifted. Let me use a different color here. Go back to black. It shifted basically to the left 30 degrees. Or you have a phase shift of 30 degrees left. Okay. So this is kind of the counterintuitive part. I mean, from here on in, every time you see a sine graph or cosine graph and you have a phase shift going on, okay, like we do over here of plus 30, you know, when we think of vertical shifts, the graph moves up, right? But here it's counterintuitive in that, you know, the graph, although it's a plus 30, it's going to end up moving to the left, which for us is considered backwards. But that's what it ends up being, okay, when you actually graph the points. As long as you keep that in your mind, you'll be okay. For the second one, and I will do that in blue, we have an h value of 90, and this one I will run through more quickly. My function is going to be, where can I write it over here? It will be f of x equals sine of x minus 90. Okay, and before we move to the left, when we had a plus 30, well, what do you think is going to happen when you have a minus 90? Okay, it's going to move to the right 90 degrees. So I'm just going to, here's what I'm going to do. I'm going to trace over my graph, my original sine graph, in blue. There we go. I'm going to go a little bit past because I'm going to have to copy this. And this whole thing, remember we said it's going to move to the right 90 degrees. It's going to go over 90 degrees. Okay. Pretty cool. Unfortunately, you can't do it on pencil and paper, but definitely helps when you have an iPad. I'm going to have to extend it a little bit on the left-hand side so that it comes down. Try that again. I'll have to come down all the way to the bottom. One more time. Over here. And on the right-hand side, I'm going to have to delete some because it goes a bit too far. So let me get my white marker. I'm just going to go over this, cancel it out. And there we go. So blue, it's ending down here. So here we have where can I put this? Do it over here. We have a phase shift right of 90 degrees. Okay, so there you have a phase shift for the sine graph, both left and right. Again, it's kind of counterintuitive, but you keep that distinction in your back pocket, and you should have no problem when it comes to graphing with a phase shift.